I got 4x times 4x squared minus 9 to the negative 1/2 power.
Okay. Let me that one more time. I wasn't really ready. You said 4x times.
4x squared minus 9 to the negative 1/2 power.
Okay. Yes, that is correct. This is how we'd see it in a more formal setting, but that's good. That does work. Um, okay, you're doing great on that stuff. Let's go to so this is kind of your classic you'll see something like this on the AP. It'll be something like x squared minus 5 to the power of 3 times 1 minus x cubed to the power of 2.
Okay. Do
This
you
is
want me
kind
to
of
do
your
that like logarithmically or just like?
no, yeah, that's not. This is meant to be a product rule problem.
Okay.
While you could use what you just said, it's not meant to be that way.
Okay. Okay. 3 times, or no, 2x times 3 times x squared minus 5 squared, or minus 5 squared, yeah, times 1 minus x cubed squared plus x squared minus 5 cubed times 3 times 2 times 1 minus x cubed.
Okay. You did the chain rule here. That was fine. That was nice. Did not see the chain rule over here.
Oh, not 3.
The
Oh,
3,
yeah.
it becomes minus 3x squared is your chain rule.
Oh, yeah. Okay. I see that.
Okay, I mean that's it. So this is on your AP. This will be a multiple choice question, and it'll be they'll do some factoring and stuff too, but we're not gonna emphasize that. That
Okay.
is something to think about. Um, so all right, here we go. You kind of alluded to this one. You
Okay.
don't necessarily use logarithmic differentiation. You do want to use properties of logarithms.
Yeah. Bringing the 5 down in front.
Yes, that will make this significantly easier to take
Okay.
the derivative of.
Okay, so 5 times 8x over 4x squared minus 7.
Like this.
Yeah.
Okay, that does work. Okay, good. All right. A little bit more with the chain rule, and then we'll go more a little bit deeper into the chain rule. So the derivative of e is itself.
Yeah. And the 8's just a constant, right? It comes down
Yes.
with it. Okay. Okay, so 16x minus 24 times e to the power of x squared minus 3x.
Now, this has to be in parentheses, what you said.
Um, does it have to? Yeah.
Yes, no, it does. So what I did notice on your quiz, like one of the ways most students learn to do this derivative is they write this and then they multiply by 2x minus 3, and they do not um you don't have to multiply unless your teacher says so.
Okay.
Yeah, it's up to you.
Okay.
Is that
That
okay?
seems easier. So yeah.
All right. Now let's try a little bit more with the chain rule here. Let's say I'm going to make one up here. J of x equals square root of sine of e to the pi x. Yeah, looks good. So give that your best effort.
Okay. Okay. So j prime of x equals pi times e to the power of pi times x times 1/2 times cosine e to the power of pi times x all to the power of negative 1/2.
Where does the parentheses start and end?
Oh, before the 1/2. There's one like the 1/2 is one its own. Oh, okay, that works too.
Well,
And
no,
there's
I'm
one.
asking. I'm asking you.
No, the
Okay.
1/2 is like individual,
All
and
right.
so is e to the x.
Yeah. There's small thing. I made this one more challenging. Maybe I should have for starting out, but this is to the 1/2 power, as you said.
Yeah.
So the derivative is what, and I'm going to ask this question. What is the outermost function here?
The outermost is the sine.
It's the 1/2.
Oh, okay. I didn't know
Yeah.
that counted as a function.
Yeah, it's power. It's the power exponent. I mean,
Okay.
it's not a function. Maybe I didn't word that well. So yeah, but the 1/2 gets brought down, and then you keep the inside function. Have you heard that language before? Keep the inside function.
Yeah.
Okay. So I knew when you said cosine, I was waiting for a sign. I was hoping. Uh,
Yeah.
so
No,
then
I
you
know.
got to take. So then your focus is just on the inside function, the sine. There, the sine is cosine. Keep that. Then the derivative of e to the pi x is e to the pi x times pi. So you were well on your way. You had pi, you had e to the pi x, you had the 1/2, you had the cosine, but I didn't see this.
Yeah. Okay.
All right. And one of your weaknesses, and I don't mean this I'm not trying to be critical, but
Yeah.
most students struggle with the chain rule derivatives. Let's look for a few more of these to work on. This is a bit extreme, but it's not out of the realm of like possibility of what you might see. So let's try to do this. Okay, here's another type of problem that you might see. And your hint here would be to convert this to cotangent of u to some power. But you don't have to do that. Or if you have no idea what I'm talking about, I can explain. But um,
Yeah. Can you explain that? I have no idea what
yeah,
you're talking.
so this is really cotangent of minus 5x cubed minus 2 to the 1/3 power.
Yeah.
And so u is really minus 5x cubed minus 2. So this is really cotangent of u to the 1/3 power.
Okay.
And so your I almost got for the wrong word. Your your derivative of this is much more basic than this up here. Like what's the derivative of cotangent?
Cosecant, negative cosecant squared.
Negative cosecant squared of the inside function. Then you take the derivative of the inside function. What's the derivative of something to a power?
1/2 or 1/3 u, and then negative 2/3.
U prime. That's the chain rule. And that's where you need this U prime over here.
Okay.
So now you have to feed all that back in.
Okay. Let's see.
So it's minus cosecant squared minus 5x cubed minus 2 to the 1/3 power times 1/3 minus 5x cubed minus 2 to the minus 2/3 power times minus 15x squared.
Okay.
So let's try something like this. I can't give you this exact one because you got this one down. But like, do you kind of following this pattern of,
Yeah.
nesting functions, nesting dolls? All right,
Yes.
let's do, let's say it's sine of the square root tangent x minus x squared.
Okay. So we change it to sine of tangent x minus x squared negative 1/2, and then my u equals tangent x minus x squared. So sine of u 1/2 times. Okay. So sine times u to the power of 1/2
Okay.
times 1/2 u to the power of negative 1/2.
Well, be careful. You've not taken the derivative of sine. Like you have to be careful. Like what you wrote
Um,
first, this is like still the original. You still haven't taken a,
Derivative of this.
yeah. You have to start with the outside function, which is sine, derivative sine.
It's cosine.
Yes, keep the inside function.
So cosine of u 1/2 times 1/2 u. No. Okay. For y prime, I got cosine.
I didn't hear anything after that.
Okay. Cosine tangent x minus x squared to the power of 1/2
Okay.
times what?
Yep.
Okay.
Go on.
Times wait. What?
Keep going.
Okay. Times 1/2 tangent x minus x squared to the power of negative 1/2 times secant squared x minus 2x.
Okay, very good.
Okay.
how is that difficulty for
Um, can we
what we're
do one
trying to
more of that?
yeah, I'm gonna make it more
Okay.
difficult, but yeah.
Okay.
Let's say it's 8 divided by e to the minus uh secant 5x plus 1.
Oh God. Okay. Um,
And this is not a quotient rule.
is it possible to bring the e to the top or no?
Yes. Yes, and
Yeah.
that's what this was designed, yeah.
Okay. And so the negative secant just becomes positive, right? Okay. Yeah.
Yes.
Okay. So 8 parenthesis or y prime equals 8 parenthesis e to the power of secant 5x plus 1 close parenthesis. Reopen another parenthesis times 5 and then secant 5x or yeah, secant 5x times tangent or secant 5x tangent 5x.
Good.
Okay. Perfect.
All right. Let me give me a moment here to look for some other stuff. Um,
Yeah.
we didn't do any quotient rule problems, which I guess we should do one. I did have one ready. Let me go find that. Uh, yeah, why not? Go ahead and then we should do I'll do some other ones. Yeah, go ahead and try this for us, please.
Okay. Okay, I got simplified. I got e to the power of x minus 1 over 2x or over x minus ln of 2x times e to the power of x minus 1. And that's it.
All over.
Oh. Uh,
You
oh.
you square the
Yeah.
bottom.
E x minus 1 squared. Okay.
Okay, so like a problem we've not done, which we were doing a while back, would be something like y equals x to the cotangent x. This is like a logarithmic differentiation problem. They don't get too much more complicated than this to start out.
Uh, we just bring both sides to ln, right?
Yes, natural log of y.
Ln equals cotangent x ln of x. And then find the derivative. Or no, it's now it becomes product rule, right? Okay. So I have ln of y equals negative cosecant x times ln of x plus cotangent x over x.
Okay, it should be negative cosecant squared, and you have to take the derivative of the
Wait,
left side as well.
1 over y. Okay, 1 over y prime. And then, oh, so then I do multiply by x cotangent of x, right? On the
Yes.
very,
Yeah.
okay,
The this part always appears in the final answer. You'll notice if if you're pattern based when you look at things.
yeah.
Okay. Any questions on that?
No.
I found another quotient rule problem for you to try. This one's in the form of multiple choice, which I'm
Oh,
okay with. Um, so you do have to simplify a little bit. It's not that bad, but just give this one a try, please.
okay. Okay. So for like my unsimplified answer, I got 6x plus 4 minus 6x plus 9 all over 3x plus 2 squared.
Okay. Um, I don't know if you put it in parentheses like I did, but that's very important to do.
Yeah, I did.
Okay. So now
So
you gotta
that
simplify the top.
so it should be just. Oh wait, no, because it's. Wait, hold on. So is it C? No, negative or D. It's -5.
Which one? Which one do you want to choose?
D.
Okay.
Okay.
Uh, the Ulditim L'Hopital's rule going forward. Uh,
Okay.
all right. So it's good to figure out which indeterminate form it is.
Okay. So I
This one
think.
is it is 0/0.
Okay.
So hopefully that helps.
Yeah. Doesn't it? So whenever I take it into 3 cosine 3x over 4 secant squared 4x, I got it comes out to 1 over 1. but I don't know if that's right.
You said this right?
Yeah,
Okay. And you can always try putting zero back in.
yeah.
So
So cosine of
did you
0 is 1, right?
right, but you still have these coefficients too. Consider.
Oh,
Like
so it's 3
they're
over
part of it. Yes. So the answer is 3/4.
1.
Okay, here is another problem to try. Be very careful with chain rule, make sure you apply it.
Okay. What's 1 to the power of 1/2?
So one to any power is always one.
Oh, okay. That's a really stupid question.
No, no,
So it's 0,
it,
0 over 0.
yeah, this is 0/0. Um, no, that's important to know. I mean, now -1 to the n is not always one, but that's yeah. There's other stuff like that.
Yeah.
Anything to the zero power is one. Um, so you will have to take a derivative of the top and a derivative of the bottom.
Okay, so okay, so when I plug in, oh wait, my derivative is -1/2 times 2 minus x to the power of -1/2
Anything else?
minus 1.
Oh,
Oh,
so
uh,
there's chain rule. There's chain rule for the inside function. Yeah, and then the -1. So this becomes plus because the derivative of minus x on the inside is
um,
-1.
okay,
You see
and
what
then all over 1.
all over one, yeah. So now you can try one again.
So 1/2 times 1 is 1/2 minus 1, -1/2 over 1.
Okay. Is that your final answer?
Yeah.
Ah, why is it
Sounds
slightly
right.
different? So I'm looking at the solution. I wonder if they have a mistake in their solution. Um, the solution is, I feel like I got a sign error. Okay. Minus x negative. Okay. I see. I think you had already accounted for it and I made you change it.
The negative?
Yes.
Okay.
So it is negative. So it does change it to -3/2.
Okay.
But that was on me.
No worries. Okay.
Okay, new problem here for you to try. Uh, we'll maybe do an optimization problem here.
Okay. Natural log of 0 equals infinity, right?
Yeah,
Okay.
from the right.
So it's
That's
infinity.
negative.
The indeterminate form is infinity over infinity.
Yes. Yes. Good.
And then, no. And then for my second derivative, or for my first derivative, I got 1 over x minus 2 all over 2x divided by x squared minus 4. And then I get
Okay.
0, 0 as my indeterminate form for that.
So did you try to simplify this at all?
No.
Okay, so you can always try, and sometimes it does work. This becomes 1 over x minus 2 times x squared minus 4 over 2x, and then the x squared minus 4 factors. And that small little thing there could make all the difference in doing this. Because you really don't want to take a derivative of this down here. Uh,
Yeah.
this is a quotient rule.
Okay.
So
So,
if you can, and we can here, so this becomes x plus 2 over 2x, limit as x approaches 2 from the right.
okay. So x plus 2. Okay. So then the answer is 1. You get 4 over 4. Right? Okay.
Okay, so some sort of an optimization problem.
Okay.
Oh wow. So actually, I helped a student today. He was at Pima. Not that that really should matter, but the teacher had him work on this, and I just found the exact same one. This whole worksheet is on the internet. I couldn't believe it. And no creativity.
Okay.
All right. I don't think we did a problem like this yesterday.
Um, I
Exactly
think
like
we
this, Mike.
did, but it was had like 4 sections instead of 2.
Okay. This one's slightly easier. One of the keys here is to label like x, x, y, 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 x, x. Could you give me the area equation and then the fencing equation?
Um, so for area, it'd be 2x times y. And then for perimeter, it's 4x plus 3y equals 102.
Okay. So could you solve this for y and
Yeah.
then let me what you come up with, and then we'll talk about what to do next.
Okay, y equals 102 minus 4x over 3.
Yeah, now I recommend dividing them both by 3 and simplifying if you can. I think that'll help when you put it back in over here. 102 is divisible by 3. Can you hang
Okay.
on just a second, please? I'll be right.
Yeah.
All right, I do apologize for the delay.
No
Um,
worries.
maybe you made some headway on this. I was
Yeah.
gonna, so it ends up that it's uh 68x minus 8 over 3x squared. Your derivative is 68 minus 16 over 3x. You set
Yeah, and
that
then
equal to 0.
x
I don't
equals
remember.
12.75.
What did you say?
12.75?
Yeah, that's right. It was like 52 over 4 or something. I don't remember. Good job.
Yeah.
So that is it. Sorry for having to take a thing there, but if you're okay, I'd like to stop here for tonight.
Yeah, I'm good with that.
All right.